Thank you, Tom, and good morning. Thanks for joining this talk. I will talk very briefly about the council. It's not worth spending a lot of time on here, and I have a very random snapshot of some Earth observation research in the Netherlands. Netherlands, you see here. If you look closely, you can see the flower fields also in there. Picture from a few years ago. But I want to focus on some other applications, the solid earth and land surface. But first, a few slides about us, the council. Like Tom said, we are a group of universities. Why we started is there was some outside demand, a funding organization that said, when we want to know something about Earth observation, we don't know who to talk to. A ministry said, we'd like to think about what we do with our money, but what should we do? And they wanted to talk to scientists and students. They were so confused looking at the possibilities in Netherlands. But the main thing also is we realized we are missing possibilities as Earth observation scientists. And the best thing to realize that if you're in Earth science is to go to astronomy. I guess it's the same in your country. If you go to this website, astronomy.nl, you see the incredible organization that they built. And you should think, is astronomy more important for society? Is it more fun? No, not really. But somehow they are a better organized field. They have better PR, and they get very big missions supported. If you go to the website here, to the telescopes and the Dutch participation, it's enormous. So we thought, there is a chance for us to also better organize and maybe create better opportunities. So we started a few years ago, and the way we divided ourselves is sort of the elements in the Earth: atmosphere, cryosphere, land surface, including water, ocean, and solid Earth. And we try to represent the cross sections of the institutes. I have to say here, the scientific institutes, the company part, we leave out of us. The Netherlands Space Office is the liaison with that. And we start together observers, people that are not member, but they like to be up to date and involved in the discussion. And that's Surf, already mentioned, Netherlands Space Office, that you'll hear both from after me. But also the eScience Center have a lecture later this week. The Dutch Research Council and the Space Research Organization Netherlands also doing a lecture here. And one of the things we did was a report. Tom mentioned it already. It's a bit political. You might not find it the most inspiring, but we had to create an overview of what's happening in the Netherlands, and we tried to come with recommendations. And one was on education. A nice sentence here, look at what's already done. But one of the things we started to think, what if you really want to do something? You can get researchers together, but they have very little time. The people actually doing the research that have the time are the ones at the start of their career, which is most of you. So we started, as we gathered last year, all the Earth observation scientists, we thought we should do a summer school. Very nice idea, everybody happy. Then we started to look around, funding. More difficult. We thought, this is a bigger project than we thought. And then Hailey from Surf brought us into contact with OpenGeoHub team. So very big thanks to you guys for letting us join and even take some space in this summer school. This was really a great opportunity. Otherwise, we would still be discussing and trying to get funding from here and there. And as you said in the morning, we're here to learn, to see how it's going. Standard is quite high. I don't know if we're able to match it, but we're going to try. But thanks a lot. We're really happy to be here. Where are the universities? You find remote sensing in a lot of places, but really targeted education in the Netherlands is in Delft, Utrecht, Amsterdam. I tried to ask ChatGPT. I thought, this should work. Make a map of the Netherlands and put the cities in there. Then the map of the Netherlands looks horrible. Then I thought, I'll give the map, put the cities there. Also didn't work. So I think I have to get used to a little bit the AI tools. But I put it here roughly by hand. And you see they're clustered somewhat in the middle of the Netherlands. Not very far apart. If you're used to bigger countries, still we don't talk a lot to each other. which is why we needed to have this council. Several master's programs, and you see a little bit the difficulty on the middle is the faculty that remote sensing or Earth observation sometimes is in civil engineering, sometimes geoinformation. Myself, I'm from an aerospace engineering faculty. We attract a lot of students. We don't really do remote sensing, which is a pity because I see our students going to the wide world with their interest in rockets and orbits, and they realize a lot of the actual applications from space is in Earth observation. So we would like to change that too. By the way, an institute that's often forgotten, but it has a very good reputation internationally is the IHE. As part of UN organization, they organize, they really gather a lot of international students for courses. And finally, institutes. Some of them you will see here, like the KNMI, the Weather Institute in Esron. We have an institute, NIOS, especially dedicated for the sea. As you can imagine, it's quite important in the Netherlands. That goes from fisheries to large-scale ocean. And also at the bottom, we have government applied research institutes that develop instruments. Remote sensing is increasing. If you look at number of publications over the years, that might not be the most important output. There's also a really big contribution to some Earth observation missions. Very old one on the left is ENVISAT. This is one of my first experiences with real space. It's led and was tested by ESTEC, which is in the west of the country, a place called Noordwijk. Some of you might have been there. I was a student at the time, and my student job was for the museum there, touring kids around. And it is impressive what it can do, but when you see a satellite, it's not so impressive. So I tried to impress the kids and saying this is 1 billion guilders or euros at the time, and they really liked it. The local newspaper was there. They put it in the newspaper. The kids get to see a package of 1 billion euro. And then I got a call from the museum, said, next time maybe focus on the nice things it can do instead of how much money it costs for the taxpayers. This was a particularly important one because at the time they thought it's better to put one satellite, throw all the instruments up there. It's more efficient. They actually realized if you do that, it becomes so complicated that this mission takes forever, which is what happened. The Dutch contribution was an instrument called Skiamaki that's scanning the atmosphere going down and cross-section. And that is a bit a recurring theme in Dutch contributions led by TNO and Esron. They focused on measuring atmosphere through polarimeter. That's on the PACE satellite. And a famous one is Tropomi, an imaging spectrometer on the right. That's on the Sentinel-5 satellite. So that's expertise that has been building at these institutes, and they developed a reputation on that. And one of the things they produce, and this is on one hand very nice, it's also a little bit depressing. I'm involved in some student projects, and they produce maps like this that show the methane emissions all over the world. Here it is the ones that are connected to gas pipes. So this is maybe just leakages. They're also from garbage dumps. As you know, methane is a very powerful greenhouse gas. The good thing is that pictures such as this are starting to create some change, and sometimes people that are responsible do act on this. A Tango mission that's upcoming is an ESA mission, but a Dutch consortium. Again, focus on atmosphere and greenhouse gases. I know Esron is involved, so you might see this in the lecture on Friday. It's a dual mission, as you see here. And finally, a Harmony mission. It's not a Dutch mission. It will be built in Germany, but the PI, principal investigator, is Paco Lopez Decker. So he came up with the idea of this mission, where there is a Sentinel satellite in the middle with the red beam. Oh, sorry. Is that okay, Beatrice? Or did I mess it up? I pressed the home button. Okay. Yeah. Thanks. Sorry. Satellites that are before and after the Sentinel satellite, catching its radar signals, studying deformation, the ocean surface. We also have a thermal infrared sensor. And Paco is here for a lecture will be here for a lecture on Friday. Also interesting is that there's some spin-off of these activities. A spin-off from the University in Delft is a company called ISIS Space. They started as from a student project. They now have supported the launch of about 400 satellites, smaller one, of course. They're really the go-to company. If you have an idea for a small satellite mission, they can do everything from building, testing, to launching. And I want to talk about some of the applications. I try to pick a few applications that are maybe not addressed or not known to most of you. Like I said, this is very random. I don't pretend to give an overview of everything. The one I've been involved in is focusing on the solid Earth. And the solid Earth, we mean really deep inside the Earth, usually. This is a mission called GRACE. I took the wrong image here. GRACE is two satellites following each other, and they measure gravity, which sounds very fancy, and it is in a way. What it does is when it flies over, let's say, a big lump on the Earth, like a mountain, the first satellite is attracted a little bit more. The second one stays behind until it gets closer. The second one is also attracted. So a mass change on the Earth is felt by the satellite by change in position, and the position changes as these satellites fly over a mass like a big mountain. Very fancy, but it's really Newton's law. There is no correction factors, no calibration. It is just Newton's law, except you have to measure this difference between the satellites' distance very accurately. When you do that, and the satellites keep flying around the Earth, it can not only measure where the mountains are, because we know that, but also changes. So a mountain gets smaller or bigger. Now, that's not the main effect. This is what, let's say, the mountains. If you would collect all gravity data from satellites, which is what people have done, and you make a snapshot of the Earth, this is what you would see. The unit is at the bottom, 10 to the minus 5 meter per second squared. So this is on top of the 9.81 that you're familiar with. And in the average picture, you see mountains, for example. You see the Andes, the Himalaya. You see mid-ocean ridges. You see, basically topography is the very first thing you see. This was sort of known for a long time. What this mission added was a change. And this is a picture I made. And just to show how different it is maybe from other Earth observation, the data is about 150 kilobytes per month. So for 20 years, it's really not a very big data set. It is a little bit complicated. It comes in to coefficients that you transform to a map, but this is a very small function, runs for a few minutes, and it produces a trend. So I'm fitting a straight line through 20 years of data. So you see increase of gravity or decrease. You also see there's some noise, and you also see this is not a very sharp picture, but that is because the satellite is about 500 kilometers above the Earth. But you could see, and the first time this came was around 2005 or 6. The picture wasn't so clear. A lot of blue areas like Alaska, Greenland, Antarctica. And what is happening there is not mountains getting smaller, it's ice getting smaller very, very rapidly. You see a big green area in Canada and Scandinavia. I don't know if there's people from those countries. You are familiar with the land is coming up there, and that is a positive gravity change. If you look in Chile and Japan and Indonesia, you see a positive next to a negative signal. That's an earthquake. So really a lot. We could see here for the first time. What is the good thing about this is you really measure the whole ice sheet. You don't have to go with an altimeter and have difficulties at the edges. You don't have to go with a stick. You just weigh the whole ice sheet. So the big applications and the big headlines in from 2010 to 2020 was all the ice being lost from those areas. I picked a sort of random other application just to give an idea of what this can do from former student. You can zoom into certain areas and integrate the signal. And this was a part of Iraq, the red area. And you just look at the time series. Again, very simple analysis. And yeah, it tells you a story of decreasing groundwater or water storage. And that, if I go back to this picture, you could see also, for example, in northern India, a big blue part, which is really losing a lot of groundwater. That's an application that people work on that is somehow remote sensing. Another one, entirely different scale, that was not started in Delft, but a big contribution in Delft was to interferometric SAR. And that's a radar. You send a signal back, and from interferometric processing, you get kind of hallucinating pictures like in the bottom right. This is a glacier in Antarctica. And from these fringes, you can derive, is this getting closer or further away to the satellite? What they realized early on is that, yeah, real groundwork is also very good. So they started to put in these corner reflectors that are very bright in a radar signal because they reflect the signal back. They developed open source software that became very popular to do this kind of processing. Here we are talking of large data sets. One of the things they produce, this is a spin-off company that's doing this, is the nice Dutch word bodemdalingskaart, the ground subsidence map of the Netherlands. It's 4 by 4 kilometer. And this gives an overview. They do this also for dikes, for railway. And it's called subsidence because, fortunately, there is subsidence in the northwest. It's an area of mostly former gas extraction that's now subsiding. And in the west, you see a lot of red because that's basically peat, former plants that are still compacting. Entirely different application is more, I think, a field known to you, that's hyperspectral imaging. But in Twente, there's a big group, excuse me, that are doing this for geology, not for vegetation, but see if you can map the geology from images such as this that has applications to mineral extractions. A few ones about ocean and land surface. And one that's a satellite mission that in Delft people have been involved a lot since the beginning of the 90s is radar altimetry. So the measurement system you're familiar with is the satellite sending a radar, bounces back, and you measure the travel time. What makes this difficult is you need all kind of corrections. You need to correct for the atmosphere, troposphere. When you see the sea surface, the first thing you will see is things like tides that you probably don't want to see because we know them, or variation because of pressure. So all these corrections you need to apply. That makes it difficult when you want to start using this data set. So one service that was started in Delft, it's now hosted at NOAA, is a database, but not only a database, but one where you can take the geophysical data records in green here, that's the original data, but also all these corrections, and you can click which tide model you want. This is a large data set. Processing is done, I guess, in the cloud somewhere, used to be in Delft. And you can get all kind of products. You want wind speed, you want wave height, you want, for example, average sea level over time. it is, yeah, developed a long time ago. So this is ancient Fortran codes behind it, an open source software called GMT. And the person developing it moved to NASA, sorry, to NOAA, and that's where it's now hosted. Interesting other application I came across is that Netherlands is sometimes good for calibrating and validating a mission. That's because it's not always clear where there's land and where there's sea. And we have a particular funny feature that's all the way on the west near Rotterdam. It's kind of looks like a sand, jellyfish that was artificially created because people try to see if instead of just putting new sand every year, what if you just put a lot of sand in the ocean? We create a small island and the sea just distributes it. It's called the sand engine, and it somehow works. It's also nice to go there and walk on it, and it became a nice site where you could calibrate how well you can determine the shoreline from optical images, because the shoreline is constantly changing there. Finally, there was a big effort on calibration, validation, and ground data for the, let's say, weather atmosphere. And this is a collection of observatories called Ruisdael Observatory. The biggest feature is a very big tower somewhere central in the Netherlands called Cabau, that's measuring all kind of meteorologic variables at different heights. That is what was especially missing. You can measure things on the ground, but people that are doing modeling, they would like to measure at different heights. And this data is an incredible long list, that most of it you can download. I just took a screenshot here. You see it's alphabetic, so we're still at the A here for air quality. So very, extensive that can be used for testing, improving models, comparing satellite data. And with that, I end my very random overview of some activities in the Netherlands. I just want to point out the lectures that are, let's say, from Dutch institutes on Earth observation. We have Sander Houweling later today on the atmosphere. Ralf Koolhaas, Jochen Landgraaf from ESROM. Jochen is on Friday. We have a lecture from KNMI later today. The Harmony mission and radar will be on Friday. Lecture on the eScience Center and high performance processing. And finally, cryosphere applications from my colleague Lou on Friday. And I would like to use the last few minutes to get some input from you, because we are hoping to organize a summer school on remote sensing Earth observation for Netherlands and Belgium. And we'd like to take this opportunity. So I have a Mentimeter question, a single one. Can I just switch to the... Yeah. So if you could get laptop or phone, go to mentimeter.com, type in the code that will be at the top of the screen. And it's a word cloud, and it asks you what topic, single or multiple, do you think should be in an Earth observation summer school? Anything that comes up, feel free to think from your own interest. What would you like to see and learn there, hands-on or software, or more focused on technology? Yeah, thanks. So it's a code on top. I will read it also if it's not clear. It's 5941 and then 5128. Good, that's working. It is anonymous, and but we will I will store this and use this as start for our discussions, because we have now a selection of topics that we thought are interesting, but we were thinking, yeah, should we cover all topics, or is that too broad? Are people interested in hardware or not? Are they really focused on applications? Yeah, we were going in all kind of directions. So I'm hoping to get some idea for this. SAR, okay, that's good. That's a big one, and we can cover that. I see it's not a bad match with what we are bringing here. The high performance computing is in there, and a lot of applications, hyperspectral, big data. I think that's covered very well in this school. Computing data formats, but also applications like aerosols, geodesy, pollutions, snow. A lot of people interested in snow. I will. We're getting good numbers here. I think that should be most of the room. Thanks. That's great participation. It's better than I usually get in a lecture of students.
These are modern students.
Yeah.
They sleep with their phones.
Yeah.
So we can get to questions, no?
Thank you very much for participating. Sure. And if there are any questions,